Let's have a look at how to solve a rational inequality. The problem we're looking at is 3x squared plus 13x plus 9 divided by x plus 2 squared. And we would like to know where that is less than or equal to 3. With rational inequalities, we need to get everything on one side, so we don't want to try multiplying both sides by a denominator in case we're multiplying by 0, or if it's negative, we would have to switch the inequality. Since we don't know that, we're going to try to get everything on one side and work from there. So the first step will be to subtract 3. Now, since we have fractions, we're going to have to get a common denominator. So the 3 we'll have to rewrite as an equivalent fraction, but we need an x plus 2 squared in the bottom. So we'll have to multiply the top and the bottom both by x plus 2 squared. Still needs to be less than or equal to 0. The next thing will be to expand the right side and then combine our like terms. So x plus 2 squared is x squared plus 4x plus 4. When we multiply that by negative 3, we get negative 3x squared minus 12x minus 12, all divided by x plus 2 quantity squared, and it still has to be less than or equal to 0. Going to go to the next slide. We'll rewrite the things that we had at the bottom of the last slide, and then we'll carry on from there. So I can combine some like terms. We have a positive 3x squared and a negative 3x squared. Once we do that, we can do 13x minus 12x, which gives us x, and then 9 minus 12, which is negative 3. And we'll still divide that by x plus 2 quantity squared, and it still has to be less than or equal to 0. Next thing we need to do is find the zeros. We have a 0 at 3, and our function is undefined when the denominator equals 0, and that happens at x equals negative 2. The next thing we'll do is draw a number line, and we'll indicate the points x equals 3 and x equals negative 2. So remember that negative 2 is an asymptote, so it's undefined there. So even though it has less than or equal to, it can never equal negative 2. So that'll be a boundary point, and positive 3 will be a boundary point, but since it says less than or equal to, if it equals 0 at 3, then we can use that. So we might have a bracket on that side. The next thing we'll do is try some values in each of those regions. Let's try negative 3. If you plug negative 3 into the inequality just above, you get a negative in the top and a positive in the bottom. So that will be negative in that whole region from negative infinity up to negative 2. Next point we'll try is at 0. If you plug in a 0, you get a negative divided by a positive. That will also be negative. The next thing will be, we'll try something bigger than 3, so we'll try 4. When we try 4, we get 4 minus 3, which is 1. The bottom's always positive, so that will be a positive number. The last thing we need to do is determine the solution set. So it goes from negative infinity to negative 2 with a parenthesis because there's a vertical asymptote there. And then from negative 2 up to positive 3. But since positive 3 is a 0 and our function can equal 0, we use a bracket on that side.